think we should get started. To make it very clear from the beginning, this is an introductory level talk about Scala. So if you are already a Scala expert, then hey, you might be interested in some other talk. But I'd appreciate if you stay, of course. All right. So I'm a liar. I have to apologize. I do have 4 slides, so this is 1. But I think the next 45 minutes, well, maybe the next 42 minutes will be just pure live coding. All right, let's get started. So, quick introduction. I'm Heiko. I'm working for Typesafe, and I have been using Java for, well, it feels like forever. And some years ago, I was looking for a new, well, tool or some new game or something to play with, programming languages, technologies, tools, whatever. In 2008, I was watching a keynote by Martin Durchstarten. You might know that guy. For those who don't know, that's the creator of the Scala programming language. And ever since then, I'm a big Scala fanboy. And today I'm trying to, well, transfer some of that enthusiasm I feel about Scala onto you guys. So let's see some Scala in action. I'm going to use Eclipse here to demo the code. There's also a pretty decent IntelliJ plugin for Scala and some other decent plugins for editors like Sublime or whatever. So let's start with looking at Scala from an OO perspective. Who of you is a Java programmer? Most of you. What are the others doing? Managing. Okay, so what programming languages do the other guys know?
Ruby, JavaScript.
Ruby, JavaScript, awesome. C, okay. A lot of these mainstream things. Great. So let's start looking at Scala from a Java OO perspective. And I have a typical Java class here for you guys. It's Java time, so it has hours and minutes as fields. There's a constructor where those fields are passed in, and then or parameters are passed in, and those fields are initialized. This is a calculated field. Then, of course, we have getters. There are no setters because it's an immutable object. Hope you know immutable object. That's not like something which is exclusive for Scala. You can have immutable objects in Java too. It's a well-known pattern. There's a minus method, and then we have those good friends equal and hash code, which are very important for entity-like classes, right? It's just time with hours and minutes, and it has some 70 lines of code. Let's try to do better in Scala. So I start creating a Scala class. So this is the default layout of a Scala project, at least if you start with AspectJ or Maven. Let's create a Scala class and call it time. So the fun thing is that this is already a valid class. It's not really useful, but we can go to the worksheet, which is a great tool in Eclipse and also in IntelliJ, where you can evaluate code, and well, that's great for experiment-driven development. So we can create a new time here and look at the result. You will find the result here. res0 is just a stupid name for a variable we could reuse later in this worksheet session. That's the type here, :type. That's the way Scala types are given in Scala. And that's, well, the result of the toString method, you know, from Java lang object, right? Okay, so it's already a valid class, but we need hours and minutes. So let's just add class parameters. In Scala, we can define parameters on classes. All right, now we have a time which can no longer be constructed like before. The compiler will tell us, hey, wait a moment, there are not enough arguments for the constructor. So obviously, if you add class parameters, if you add parameters to a class, the Scala compiler will create a constructor with those parameters. Okay, so we have a constructor with that signature. So we have to pass in 10, 20, that's the current time, and hooray, we can create a new time again. Let's assign it to a variable, a local variable. We use the keyword val for that. Val means value, which means immutable. There's also var for, well, mutable references, mutable variables. I'm going to use val here, so we can reference it later. So we have hours and minutes. Hopefully, let's give it a try. No, we can't access those guys because they are just class parameters. They are constructor parameters. In order to have hours and minutes as fields, or let's better say properties on this class, we have to make them fields. Fields are defined with the val keyword. So what we could do now is val h equals hours. So that would be the equivalent of what Java is doing here. But yeah, then we could access h. As you can see here, the value is 10. But of course, we have a name conflict now. We can't call that hours, and it's all boilerplate. So what we can do is just add the val keyword here, and that will tell the Scala compiler to promote these constructor arguments to fields. So the Scala compiler will create all that boilerplate code under the hood for us. It will create fields, it will create those assignments in the constructor, and so on. All right, so we're almost there. We still need this minus method, right? So methods are defined using the def keyword, and we need another time. So just to show you, this is the minus method in Java. It returns an int, so that's the difference in minutes. And methods in Scala are written that way. I'll be explicit about the return type now. It's not necessary, but it's good style on the public API. And, well, let's first just return some int value to make that compile. We need this as minutes to make the calculation easier. So let me first define a field as minutes here. Using the val keyword again, equals hours times 60 plus minutes. All right. No, sorry, not minus. Minutes. All right. So this defines a field as minutes. And here I'm using, or have used, type inference. So in Scala, we usually don't have to tell the compiler which type a certain expression has, a variable has, or a method has, because the compiler can figure out, it can infer the type. On the right-hand side, we have obviously something which is an int value, therefore the compiler will make that an int value. That's statically typed. We can tell the compiler this is a string. This will be a type error, okay? So we can make it an int if we want to. And again, it's public. We can access it, so we should give the type. That's just a good style, which Martin Jesse didn't mention in his style talk. Anyway, so we have as minutes, and we can use that value now to calculate the result, return, or the result of that method. This dot as minutes minus that dot as minutes. Methods are defined using the equal sign, so it looks almost like a value definition or field definition. It's a one-liner, so we don't need curly braces. We can add curly braces, and we have to add curly braces if there are multiple lines. And we don't need the return keyword because a block of code, even a one-liner, has a value. So the last expression of the block of code is the value. Okay? So we could do some things here. Add 1 plus 1. It will still return the value of that expression. Okay? So therefore, we can get rid of all that. And we can make it a one-liner like this if we want to. All right. What else do we need? Oh, I want to show you something first. So we have a time here. Let's call it time 1. And let's create a second time, time 2. Now it's already 10:25. So let's do time 2 minus time 1, and obviously that returns 5. We can use so-called infix operator notation, which means we can call methods which have one argument without the dots and the parentheses. It's a matter of style or taste, which one you prefer. But the purpose will become obvious if we start adding another method with a fancy name, with dash, with a minus operator. And that's just an alias for this one here. Okay? So we delegate to the letter minus method. And well, we could do the same. Time 2 dot minus time 1, but that's terrible, isn't it? So therefore, for those symbolic method names, some symbolic operators, we would probably want to do that. Okay, so in this case, you really have or should use the dot free notation. So we almost have the same features like this Java time. What is missing? Equals and hash code, right? Well, we could implement them on our own. As you can see here, so that was generated by Eclipse or IntelliJ, I can't remember exactly. But as you can see here, hours and minutes are taken into account. So usually that's what you do. If you have a Java bean which has some fields that define the state of your entity or of your Java bean, you usually take all that field into consideration when creating an equals and hash code implementation. So the Scala compiler can do that for you by just adding the case keyword here. A case class has some additional features. One is that you have a good equals and hash code implementation based on all those parameters here, which is hours and minutes. Not based on the field as minutes, but on the parameters. Additionally, we can get rid of val because the parameters are promoted to fields automatically, so they will become vals. So let me show you that. Oh, one more feature, you can create instances of time now without the new keyword. That's probably the most less important feature, but anyway, it's not. So time 1030. Oh, as you can see here, case classes also have a nice, well, decent to string implementation. 1030 equals time 1030. Big surprise, that's true, and that's not true. By the way, yeah, question. What is that? Equals. It's a method, very good. Because in Scala we don't have any operators. Well, the assignment operator. But we only have methods. So it's a method which is defined on the root of the Scala type hierarchy. This class is called Annie, and it has this equals method. I can show you if you don't believe me. So here's the Scala API, Annie, and it has this equals. And that just delegates to the normal equals method. So it's just an alias, so to say. All right, so that's the proper way to compare objects for equality. In Java, that would be a mistake. In Java, you would compare objects for identity. If you want to do that, there's the EQ method. But you usually don't do that. There are just rare cases, I'd say, like 99% of the cases you want to do that. All right, so that's what you get from case classes. So the last thing I'd like to show you here is a cool feature. We can add defaults to the parameters of classes, well, constructors or methods. So let's add default 0 here and default 0 here. Now we can create time instances like that, time 10. All right, so time 10 will be 10 hours and 0 minutes. Quiz. How do we create a time instance now where we have, well, where we omit the value for hours? Any ideas?
Could use keyword arguments to say minutes equals 30?
Yes, indeed. So that's the way how to do it. It's called named arguments. Minutes equals 10. So this will create a class with 10 minutes and 0 hours. Okay? And you can always use named arguments, by the way. even if they don't have a default, right? Okay, so if you look at that class, it just has some, 8 lines of code, and it even has a little bit more features than the Java one here. So I think that makes it pretty obvious that you can write very concise code in Scala, very concise object-oriented code. And yeah, you hopefully like that feature. It's less, so the Scala code is less noisy. It really has a very high density of information or relevance. Almost every character, well, not really, but most of the words and characters here, well, carry information, relevant information, right? There's low noise. And that's great. If you have to maintain that code, if you have to read and understand that code in order to maintain it, you will save some time. I mean, most of us Java developers are able to have a mental filter and ignoring all the getters and setters and stuff and trying to figure out what's the essence of those 70 lines of code, because the essence basically is this here, okay? And maybe then that and that and that. So that's the essence of that. And I think Scala makes that pretty clear. All right. By the way, if there are any questions, feel free to fire them at me. Oh, no, you can't, because Scala wouldn't be able. I mean, now you have a default, but no, you can't. So you always have to be precise here. So Scala has well, the type inference in Scala is local. It's not global, like, for example, in Haskell. So you always have to define the parameters, the types for the parameters, right? Because how should Scala know that this parameter that is of type time? It's well, it is possible. There are program languages where it's possible from looking at what you're doing with it, but it's kind of hard in an object functional language like Scala, including subtyping, or it's probably impossible. At least it is not possible in Scala. Okay, so the next thing I'd like to show you is well, an application of functional programming. You probably know that Scala is a hybrid, or yeah, a multi-paradigm language which has support for object orientation, but also for functional programming. And you can look at, or a good example for functional programming, applied functional programming, are collections. So let's create a list of numbers, just a very simple list. So let's just add 4 and 5, right? We're doing it like this. So we use the collection type. We could also use set or something vector. We're going to use a list here. And then we just enumerate the elements of the list. So this will give us a list of int. So again, type inference is happening. The compiler figures out the type of this thing. What do you think will happen if we convert that to a string? Oh, sorry. What would be the type of the... Oh, would it compile? And if yes, what would be the type of this list? Yeah, list of any. Because it's not illegal to do that. Now we have various elements of various type in that collection. So the compiler has to go to the least upper bound, to the next best supertype, so to say. Okay. But of course we can't do like list of, so that's like generics in Java, list of string. So that again would be wrong. Or if you want to make that a list of int and use a string here, that would also be wrong. That would be right. That would compile. Okay, let's get rid of the type annotation here. It's just a local variable, list 1, 2, 3, 4, 5. What can we do with that? Well, the usual suspects like size and the things you know from Java. Okay, no big surprise. There are interesting normal methods like head. Do you know what head returns? The first element. So in this case, it's 1. And if you want to know the rest of the list, it's called tail. So head and tail together are the whole list. And that's, well, for every sequence. Those methods are defined. If you need more power, you can even call take. So let's take 3 elements of that list. Or number drop the first 2 elements. And then you will get 1, 2, 3 for the take. and here the first two are dropped, right? And I'm using Infix Operator notation here again, because I really prefer it. So, but that's not functional at all. That's not yet functional. So functional means, well, programming with functions and immutable, well, at least in most cases. List is immutable. If I append or prepend something, I get back a new list. So if I want to prepend 0, I could do it like this. Okay? Oh, that's called number. That's stupid. Okay. It should always be the plural. Anyway, and if I assign it, I can't assign it to number because numbers are val, right? That would be a compilation error, so I call it number 2. And number, the original list is still 1, 2, 3, 4, 5. So we have an immutable list. So if we mutate it, we get back a new list. In Scala, we have immutable collections and mutable collections. Usually you should start immutable because you have various advantages. It's easy to reason about. For concurrency, it's better. And sometimes the performance is even better. Okay? I don't want to go into the details now. But I want to show you functional stuff. And let me get rid of that again and rename it numbers, because I think that's really important for making the code understandable. So let's assume we want to add 1 to each of those numbers. In Java, you would probably create a loop, and you could do the same in Scala too. Before that, you would create a new list and then take out in that loop each element of the original list, add 1, and put it into the new list. So imperatively, you would have mutable state and variables in loops. In functional programming, you have a high level of abstraction. You just define what you want to do, not how you want to do it. So there's the map method. Map is a transformer. It transforms a collection into a new collection. Okay? So it takes a function which is the receipt, the recipe to transform each element. And functions are written like that, or functional literals are written like that. And what we want to do is take a number and add 1 to it. So that looks like a method, a little bit like a method. So you have a parameter here, and we have that arrow goes to, that's how I call it, and that's the body. It's a little bit like a method, right? So if we do it, we get back a new list, 2, 3, 4, 5, 6, right? Because we added 1 to each element. And by the way, that's also called a lambda, and that will come in Java 8. You probably already heard about that. Syntax is almost the same. I think right now this is the syntax in Java. So why wait for Java 8? You can already do it in Scala. And by the way, Scala collections or functional programming in Scala with collections is way more powerful than in Java 8. Anyway, so we have mapped this collection. There's another interesting method called filter, which does not transform a collection, but well, filter out, filter away, or filter in certain elements. So we could do numbers filter, and now I'm using that notation, if you prefer that. Just filtering the odd ones. Number modulo 2 equals 0. So these are the even ones anyway. Okay, so we get back a list of int again with only 2 and 4. All right. So we can even combine that. Numbers, map, and now I call it just n to be a little more concise. And then we filter it. N goes to n modulo 2 equals 0. Okay? Wow, and we get a list 2, 4, 6. Because first we added 1, and then we filtered only the even ones. So this is one of the examples where Martin thinks it's better to use dots and parentheses. Anyway, I hope the message becomes clearer that with functional programming, you have a high level of abstraction. You tell what to do and not how to do it. You don't create a loop or recursion. These are the usual suspects for iteration. and just describe what to do, declare what to do using those functions, those function literals. Now the cool thing is, Scala is an object-oriented language, so everything is an object. Even functions are objects. So we can assign those lambdas, those anonymous functions, to vals. So we can assign it to a val. Now that doesn't compile. Any ideas why? It's what you asked before. Now the compiler does not know that this is an int. We could omit the int here because of the contract of map, because map requires a function here to take an element of the collection. So, and numbers is a collection of int. This information is not available here, so we have to make it clear. So we have add1. And now add1, that's a function. We can call it. Functions can be called, but just, well, calling them like expected. And we can use it, sorry, numbers map add1. Woo, cool. So now we have a function we can pass as a parameter. We can, well, use locally or pass it around. It's a real first-class citizen in Scala. And what's even nicer, in an object-oriented language, you usually would encode your functionality in methods, right? So we can define a method, or let's define a class adder that takes an offset of int and defines a, well, def add method that takes an int and just adds the offset plus n, right? So that's a nice class. We can create val add 10 equals new adder 10. Now we have adder. We can then call add 10 dot add 5. That should be 15, right? Okay. Now we can use this nice method here, the adder add method, and feed it into the map on numbers. So this is a method, right? And we are just using this method like a function. We are not applying any arguments to it like we did here, but we're just using the method like a method handle. It's not a method handle, but anyway, it looks like, right? So this is really the very nice fusion which Scala offers us, the fusion between object-oriented and functional, okay? So functions are first-class citizens. Methods can be used as functions. They get lifted into functions automatically by the compiler, which we are doing here. And as you have seen up here, the functional programming helps in rising the level of abstraction. So you just declare what you want to do. That means less code, less chances for errors, easier to understand. In most cases, you don't care about the implementation details of map, whether this is using recursion or iteration. Sometimes, if you care, you still can use loops and vars and stuff in Scala. And interestingly, the internal implementation is using, oh, it doesn't move there. Anyway, so internally, the Scala collection library is using mutable state. Like Martin told yesterday, if you use it locally, not as a shared mutable state, but locally, it's okay in certain reasons, for performance reasons, for example. All right. So, any questions regarding functional programming in Scala? Okay. So next thing I'd like to show you is something called traits. And I have a little example here, blueprint outline here. Sorry. Okay. I'm moving there. I've prepared some code for you guys. Where is it? Here, animal. Okay. So here's an animal. No, here's birds and fish. Bird can fly and fish can swim while just returning what they are doing, right? That's nice, but if we want to create a duck, we are stuck. Because ducks are, well, they can fly and they can swim. They clearly are birds, right? So we would extend bird. But now we would like to also extend from fish. that doesn't work. On the JVM, you don't have multiple inheritance, and that's good because of the troubles with multiple class inheritance, diamond problem, and so on. So that's not possible. How can we get that swim method into into Duck? Well, we could copy it. We could, well, introduce redundancy, but that's probably a bad idea. We really would like to reuse it, assuming that ducks swim like fish. All right. So what we could do instead of that here is defining a trait. Traits look like classes. They're almost like classes. They're always abstract, but still they can define concrete members. They can have vals and vars and defs. They can have a concrete def here. Well, it needs a name, obviously. And now we can make the fish a swimmer. And we can also mix the swimmer trait into duck using the with keyword. And now, what we can do now is we can create Donald. And Donald can fly. Hooray. And Donald also should be able to swim. Yeah, auto completion tells us, and hey, it's working. Going back, you have seen that we get something like multiple inheritance by defining a trait and mixing that trait into fish and into bird. That's pretty cool. And you will never get a diamond problem because the Scala compiler can always linearize all the types in question, all the traits and classes in question. There are some details to know. So if you're going to ask, okay, if I mix multiple traits into my class and those define the same members, so there are rules in the compiler that, well, either it compiles, then all is fine, the compiler can linearize it, and it's always clear what super means, or the compiler does not compile it and tell you, no, you can't do because, right? So it works. In most cases, you will build traits which are distinct, and you won't run into these problems anyway. So the swimmer trait defines the swim method, and then you, I don't know, define another trait, foo, with a bar method, and sort of bar val, I don't know, bar equals bar, and so on. So no issues would happen here. And you can mix multiple traits into a class by just adding with and with and with. Okay, so that's a very important feature. Traits even have the power of, well, being used as a module system. There has been a very nice talk by Dennis Spiewak at Any Scala, which is available on the Any Scala website. I encourage you to take a look at that. But yeah, for the very basics, you get a way to compose your classes from mix-ins using mixing composition. That's more flexible than just building a large inheritance hierarchy, right? Because you can have fine-grained traits which you mix into your classes, and so hopefully get a little bit of reuse and flexibility in your class design. All right, so it's 10:48. I think I have almost, still 10 minutes. So the next thing I would like to show you, I can't do live coding because I'm running out of time, is a nice little demo showing the integration or the compatibility between Scala and Java, because in Scala you can use any Java code you have written or any of your favorite libraries. It's downwards compatible. So let's go to here, this JavaFX user interface for the game of life. Do you know the game of life? Conway's game of life? It's a simulation, well, of life. There are very simple rules. There are cells. They live on a grid. They can get born if they have 3 neighbors. So they need 3, not 2 like we. But they can also die from loneliness or overpopulation. They only will survive if they have 2 or 3 neighbors. These are all the rules. So they die or get born from generation to generation. And that opens up for very interesting results. So I will first run that program here. Oh, wow, that's great. I have some issues with my... Oh! That's Java 6. Okay, so I'll fix that. That's easy. J0 and go back to Java 7 because Java FX is not included in Java 6. Okay, so I have to recompile it again. I'm sorry for that. So I'll show you first, some examples for that simulation, which are really interesting, and then go and take a look at the code. So you can define some of those first generations and then run the simulation. I'm defining 3 examples here. So that's a blinker, that's a constant one, and that's called a glider. Look at Y. So the blinker always changes its shape, and the glider glides away, changing its shape after the first iteration. It's the same shape again, and now, well, it's gone. And that's a constant thing. And some others just disappear. They completely die. Such a population just goes away. And, well, that's really a simulation. And the implementation here is not, like, suitable for huge grids, or it's not optimized for performance or scalability or any of that, but it's very idiomatic Scala code. So first, let's take a look here. Yeah, that's the UI. It's kind of ugly code because it's JavaFX code, so you need a lot of those typical UI things to do. But it's written in Scala, and it's using the JavaFX API. So yeah, you can use any of your Java libraries. But let's take a look at like the business part of that, a business layer of that implementation. So the generation is probably the most interesting class here. So generation is a class which has alive cells, which is a set of cell. Again, by default, it's empty, so we can create a generation just without alive cells. And then we have the next generation, the functional style. So a generation can be called to return the next generation, okay, as a new generation. So it doesn't change its state in place, but it returns a new generation. And that's, well, a generation with alive cells which are staying alive and get born, okay? So plus plus just creates the union of those two sets. And staying alive, again, there's a functional way to do that. We use that set, alive cells, we call it filter method, and we provide a filter. Well, hopefully it's clear what that filter does. This function can stay alive. Well, it defines, or it just returns true for those cells which, well, can stay alive. It's implemented like that. 2 or 3, which are the numbers of neighbors you need to stay alive, contains, well, the alive neighbors of that cell size. I don't want to go into the details too much, but as you can see here, it's a very, very concise implementation. Just 40 lines of code, one-liners, most of those. So it should be pretty easy to figure out the details and hopefully maintain that stuff. All right, so last but not least, let me show you one more thing. I have to quit that first and go to the next one. So I want to show you parallel collections. In Scala, you have a collection library with normal collections, so every invocation of map or filter will run sequentially through all the elements. But there's also parallel collections, and they, well, speed up your program, as we will see soon. So here's a weather application which gets the weather from a web service for those 24 locations, and then basically just creates a average temperature here. So that's interesting code. Let me just run it first to show you what's happening. So if I run the weather service demo, number 2, you'll see, well, that's pretty slow. It takes half a second for each of those cities. It's very, very slow. So it will probably take 20 seconds to complete the whole calculation, or at least 10 seconds. And now I can run it in parallel by just using a par parameter, because that's how the program is written. So as you will see, well, it's very fast. So what do you have to do to get that speed improvement? All you have to do is take the locations, that's this list, okay, it's a list of, well, in this case, strings, and call .par. So this will transform this collection into a collection where not all, but most of the operations you can call, like map or filter, run in parallel. That's all you have to do. You get back a parallel collection. And that's pretty awesome. It's not a silver bullet, but whenever you have a use case like that where you want to compute something over a huge collection, that might be the right tool. There are other tools like futures or maybe even actors, but Jonas just had a talk and gave a talk, and he mentioned that you should start with the, well, simple tools, and that's a very simple tool. All right, so I think that's what I wanted to show you. Thanks a lot. You can take a look at the code. It's up on GitHub, and I think we can still answer a couple of questions. Yeah.
When does you get insight into when one would use trait versus, say, like an abstract class?
So an abstract class can have class parameters a trait can't have. So if you need class parameters, you must use an abstract class. In all other cases, you should probably start with traits because then you have more flexibility. There might be a compilation speed impact, so it looks like abstract classes are a little faster in compilation. But usually, again, I mean, start with the most flexible solution, and that's traits. You also had a question.
How hard would it be to make the live simulation in parallel collection?
Very, very easy. I mean, all you have to do is add the .part to the collections and maybe some other tweaks, but it's like probably just 3 or 4 lines of code I would have to change. Yeah.
Is that a book as well, Scala in Action?
There's a book, it's called Scala in Action. Yeah, it's written. No, it's not related. Well, it's written by my colleague, but it's not related to that. But it's good. All right, no more questions. Thanks a lot. Enjoy the conference.